Well, good day, everybody. We are ready to start section 6.3 on factoring trinomials with a leading coefficient not equal to 1. And so if we have a leading coefficient not equal to 1, then our goal at that point is to break it down in a little bit different way. So let me show you a quick example here, and we'll talk about it and how we can work through this. Okay, here's our example right here, 2x squared plus 5x plus 3. And we want to factor this polynomial. And the difference we have is the leading coefficient, the value times the x squared term, is not equal to 1. Now, in this case, that's not so difficult because we know that if we break this apart, that we know that there's only one way to get 2x squared, and that is 2x times x. That gives us 2x squared. And so then we need to break the 3 apart in such a way that when we multiply, we get the 5x. Now, by this method, which I like to call logical guess and check, all right, I start off with the 3, and I know the only factors of 3 are 1 and 3. And I either have a positive 1 times a positive 3 or a negative 1 times a negative 3. And just like before, we're looking to see 2 positives will add to give a positive, while 2 negatives will add to give a negative. And when they multiply, they both give a positive. So it turns out that the 1 and 3 is the only choice, and we're going to choose the positive ones because this middle term is positive. So that's the same process as what we've had before. However, when you add 1 and 3, you only get 4, not 5, which is what we have in the middle here is the 5. And so what's going on? What's different? Well, what's going on is you're multiplying by the 2x when you multiply. Now, when I first learned this, I would just guess and check. I would put the 1 here, and I would put the 3 here, and then I would check. That is 1x, and that is 6x, which adds up to 7x. Oh, that doesn't work. So I would come and I would erase those, all right? And then I would switch them around and put the 3 and the 1, and then that gives me 3x and 2x, which adds to 5x, and that was correct. That was the correct way to do it. And so that's how I learned how to do it. But as I taught longer, I sort of found a more direct way to do that. And the way to do that was to do what is called the AC method. The AC method. And so I want to talk to you about the AC method, but I want to flip to another page. We're going to do this problem again. We're going to do it by the AC method. And I don't care if you're really good and you can do logical guess and check and get these, then do that. But if you're having problems factoring, then doing the AC method is really a good way to break these apart. So let's talk about that, and I'll show you on the next page. All right. So I learned the AC method while I was teaching algebra many, many years ago in the 1980s, if you can believe it. And when you look at the quadratic you're trying to factor, the ax squared plus bx plus c, the AC method refers to the leading coefficient and the constant term. And what you do is you multiply a and c, and then you find all the factors, of that AC, and that's the process. So what we would do here is we would take 2 times 3, which is equal to 6. And then from the 6, we would list all the factors. 1 times 6, 2 times 3. That's all there is. Now, we know since it's a positive 6, 2 times 3 is a positive 6, we know it's a positive times a positive or a negative negative. All right? And we know now we're going to look for the ones that add to 5. And so plus 1 plus 6, that adds to 7, -7, 5, and -5. And the one we want is the one that adds to the 5. So once we've decided that +2, +3 are our choices, then we can finish the problem. So 2x squared plus 5x plus 3 is equal to 2x squared. And then what I do is I take these two numbers, the 2 and the 3, and I put plus 2x plus 3x, because that's how the 5x was divided up in the plus 3. So I just rewrite, all this is a rewrite of the polynomial, okay? Once I do the... Okay, sorry about that. Had a little racket in the background going on, so I paused till the racket was done. Anyway, as I said, the 2 plus the 3 that we found here that equaled 5, after doing a times c, we then rewrite as 2x plus 3x, because that's how we get the 5x. And then what we do is we factor by grouping. We use our grouping methods from section 6.1. So we go 2x times x plus 1 plus 3 times x plus 1. And that will give us then x plus 1, factoring out the common group, okay, times what's left, 2x plus 3. And that is our factored polynomial. Now, just so you know, this AC method works on all quadratic trinomials. It works for all of them, as long as they follow the x squared plus x plus constant pattern. All right. Now, I want to show you one other option that's sort of a modification of this that I have seen students do in the past. So same problem, 2x squared plus 5x plus 3. And so I'll see students do 2x times x. They'll make a little box like this. And 2x times x is 2x squared, so that's correct. And then for the 3, since there's only one option, they'll put 1 and 3 like this. And 1 times 3 is 3, so that works. And then they do 3 times x is 3x, and 2x times 1, like this, is 2x. And if it didn't work, if they didn't get 5x, then they would erase and they'd switch positions. In our case, we got the 5x. And so our answer would be then the 2x plus the 3 and the x plus 1. And this is called using the area model to help you multiply out. It just gives you kind of a visual to multiply out. Now, in all cases, I don't care what you do in terms of the method that you decide to use or the method you were taught. You may have been taught a slightly different method, and I'm perfectly happy for you to do that. I'm going to kind of run through all the methods, and I'm going to do a few examples now on the next couple of pages. Okay, here we go. Couple of examples. Gonna work our way through this. So the first one, I'm going to demonstrate AC because it works in every case. So A times C is 5 times 6, which is equal to 30. And so the factors of 30 are 130, 215, 310, 5, 6. And I am looking at the 2 and the 15 because they add to 17. And they'll both have to be negative in this case because you want it to add to negative 17. So therefore, I can write this problem as 5y squared minus 2y minus 15y plus 6. There's our negative 17y right there. So now I factor by grouping. So I take y times 5y minus 2 minus a 3, and that'll give me 5y minus 2. Now, why did I factor a negative 3 here? Because I want to make sure that my group is the same. And so if I had only taken a 3, I'd have had a negative 5y plus 2. And so taking the opposite sign makes them the same. At that point, I factor the group, 5y minus 2 times y minus 3. And I've got it. Okay, next problem. All right. Now, next problem I'm going to do by just my guess and check method. All right. And so just so you can see it. So 3x times x. All right. And for my work, I have negative 28 that I have to break down. So 4 and 7, 2 and 14, and 1 and 28. Those are the options. Now, as you notice with guess and check, you really do have to guess and check. And I've got to get a negative 25 here. So since I want a negative, I'm going to do, let's try negatives. Sorry, I apologize, something's not quite working right. There we go. I'm sorry about that. I had an issue. I must have clicked a funny button. Anyway, so now we're back. So here's the struggle with this guess and check method. I'm really good at it. And what happens is if it doesn't work right away, I'm going to try the 4 and the 7. One of these is negative and one is positive. I'm going to let the bigger one be negative. And so I'm going to go plus 4 minus 7. And that's 4x and negative 21x, which is negative 17x. That doesn't work. And now I might switch them and it won't work either. And then now I got to check some more. And so one of the problems with logical guess and check is that you got to be good at working through your list and then checking each time. And so since that didn't work, this is one of the reasons why I like the AC method. Because it gives me the correct factoring right away. So I take 3 times 28. 3 times 28 is equal to 84. All right? And then the factors of 84 are 184, 242, 3, 28, 4, 21. And by the way, this is a negative 84. And so that means the larger one is negative because we got a negative 25 here. And I'm only going to go up to here. I'm not going to keep putting factors because I found the one that works. It's 3 and negative 28 gives me negative 25. So right off the bat, I can go 3x squared plus 4x minus 28x minus 28 and, or excuse me, plus 3x. Put the wrong one there. And I can go ahead and do the factoring really, really quickly. Oops. Minus 28 times x plus 1. Okay? And then that's going to give me x plus 1 times 3x minus 28. And there you have it completely factored. So this problem shows why I like the AC method over guess and check. Because with AC, once I find the right pair, I can go right ahead and do it. And I'm just looking at the pairs of numbers to get the right number. Whereas in guess and check, when your coefficient is not 1, it's really hard. Sometimes you end up checking 5 or 6 different factors before you get the right one. And that's just something I thought you might want to see. So let's go straight to the AC method now that we've seen its efficacy. 15 times negative 2 is equal to negative 30. Okay? So that'll be 1 and negative 30, 2 and negative 15, 3 and negative 10, 5 and negative 6. So there's the right choice, because that adds to negative 1. And that's because it was a negative 30. One's positive, one's negative. And the negative one's the bigger one because I have a negative right there. So I can now just rewrite the problem. 15y squared plus 5y minus 6y minus 2 equals common factor in grouping. 5y gives 3y plus 1. And then a negative 3 will give me 3y, or excuse me, a negative 2 will give me 3y plus 1. And then we factor the common group, 3y plus 1, and we get 5y minus 2. And so there's our complete factorization. So there's some examples. So now let's go to the next page and do a couple more complicated examples using the AC method. Okay, 3 more problems, 3 more examples. So let's get started on these. So the first one, notice we have an xy in it, and x squared and y squared. So AC method will still work because this follows the quadratic form. And so we take 12 times 12, which is 144. And now we're trying to find the factors that'll add to negative 25. That means these are both negatives. So negative 1, negative 144, negative 2, negative 72, negative 3, negative 48, negative 4, negative 46. Is that right? No, negative 36. Sorry. Now we're getting close. Notice this adds to negative 40, so we're getting close. 5 won't go in there, but 6 will. Negative 6. And into 14, it goes 2 and 24, 4. So that adds to negative 30. So the next one's probably correct. So 7 doesn't work, so we'll try negative 8. And that goes 1 time. And then into 64, it goes 8. Oh, that's negative 26. So then we try negative 9 and negative 16. Oh, there it is. There's our negative 25. Adds up to negative 25. So now we can do the factoring by grouping. 12x squared minus 9xy minus 16xy plus 12y squared. All right. So common factor here is 3x, and we're left with a 4x minus 3y. And then here we'll factor out a negative 4y, and we'll get 4x minus 3y. So the groups are the same. So we factor the common group, 4x minus 3y. We write what's left, 3x minus 4y. And there is a complete factorization. Okay? Now, the next problem, 9x squared minus 6x minus 24 brings up another issue. If I look at that, I go, wait, 9 and 6, 3 goes into both of those, and it goes into 24. So the very first step on this problem is a common factor. So we get 3x squared minus 2x minus 8. And then I do my AC method with the quadratic inside. So 3 times negative 8 is negative 24. And they're going to add to give a negative, so the larger one's negative. So I write out what these are. So 1 negative 24, 2 negative 12, 3 negative 8, and 4 negative 6. That's the correct choice. So then this 3, I still keep the 3, and then I'll just do a bracket now, and I'll write 3x squared plus 4x minus 6x minus 8. And then now I'll do the grouping on the inside. That's why I have the bracket. So on the inside, I get an x times 3x plus 4 minus a 2 times 3x plus 4. Okay? And then still keeping this 3. On the outside, I factor the group, 3x plus 4, and then write what's left, the x minus 2. And there's our complete factoring. Okay? So sometimes you got to get a greatest common factor out. And that's essentially what happens on the next problem as well. So let's go ahead and do that one. All right. And so what we see here is, once again, 3 goes into all of these. So we take out the 3, and we get 2x squared minus xy minus 6y squared. Then we do 2 times negative 6, which is negative 12. And we write our factors. 1, negative 12. Why do I do it that way? Because it's a negative when we add them. So I want the negatives, I want the bigger one to be negative, right? And then 2, negative 6, and then 3, negative 4. So this is the right choice because that gives us a negative 1. So I go 3 in brackets now, which is just putting things outside. Just making sure I keep the 3, 2x squared plus 3x plus 3xy minus 4xy minus 6y squared. Okay, equals 3. And now I do the grouping, so I'll have an x times 2x plus 3y minus 2y, and that'll be times 2x plus 3y. And then we can wrap it up. 3 times the common group, 2x plus 3y, times what's left, x minus 2y. And there you go. So these last two problems are examples of completely factoring, right? Completely factoring. All right. And we are going through that list that I gave you. We look for greatest common factors first. Number two, then we look at two-term polynomials. And we're looking for special forms here. And for the two terms, we're looking at x squared minus y squared, x cubed minus y cubed, and we'll do these in x cubed plus y cubed. And we're going to do these in the next lesson. And then number three is the three-term polynomials. And in the first thing we look for here are the special forms. And so that's a squared plus or minus 2ab plus b squared. We're looking for that pattern. And then b, we do the ones where a equals 1. And then c, we ask ourselves if a is not equal to 1. All right. Both of these we can do by the AC method if we wish. Although guess and check works pretty good on this first one. But it's inefficient on the second category. It's more efficient to do the AC method. Okay? I'm trying to think. Oh yeah, and then the fourth thing is four terms. All right, which we do by grouping methods. And you'll notice that what we do with these AC problems is we turn them into grouping problems. All right, because grouping problems are just greatest common factor problems. And then I would say the other thing you do is you always check. Always re-multiply to make sure you get what you started with. Okay, re-multiply. If you do that, and that's your check, if you do that, then you always know if you have the right answer. Okay? So, this is what we were doing on these last two problems, is we're completely factoring, but right now, all we have are the greatest common factor methods, and a equals 1 or a is not equal to 1. So that's all we've done so far. We're going to come back and we're going to pick up all the special form things and do those. And we've also done grouping too, so we've done that. So the next couple of lessons are going to work on the special form factoring, and then we're going to mix them all up, and your job will be to go through it. You become a good factorer if you can see what to factor when problems are mixed up, when it's not just the same problem type all the time. All right, that's all I got for you today. See you next time. Hope this helps. Bye.